Alright, so this is day 3 of the CBEST question. It's been a long and arduous journey. Is that convincing enough? Hey everyone, this is Chang here. Welcome to my channel. Today we're talking about, like I said, day 3, right? The third section of this whole video series of CBEST questions. Now, once again, each and every one of these series is going to contain 5 questions. So here's a little fun math question for you, right? If there are 50 questions in the math section for the CBEST exam, and we're going to go over a practice exam, and I'm going over 5 questions every single video, about how long is this video series, right? Daunting. All right, anyways, so for today is actually quite interesting. Just by sheer happenstance that the 5 questions that we are going to talk about today, not all 5, but a bulk of them is actually going to be focused on one specific topic. So once we get into it, I'm going to explain in more detail what that topic is. Now, for today's video, once again, I hope you guys get more than just here is the problem, here is a way to solve the problem, here is the answer. Because guess what? I'm leaving the link in the description down below. You can see the practice exam. You can go through all of it in one sitting. You don't need to go through all 10 video series, right? There's the answer. It gives you the entire answer key there. So you already can see the answer. Once again, no need to go through the entire video. What I'm really hoping that you get from these videos is not only seeing how to solve questions that are presented and similar questions, but how to improve on it. What I mean is by looking at a question and understanding the basic structure, what are potential variations, right? It builds the skill of you being able to create questions itself and branching out so that you can truly test and truly understand the core topic. Because only when you are able to create variations of the problems and be able to solve it, not just create it for, complication's sake, right? And be able to solve it, that you truly master the topic that it is presenting to you. And, it doesn't hurt to be able to just create problems on the fly. So let's talk about the first of these set of problems today. Alright, so the first question, if you haven't watched the second video series, right, there's one topic that came up a lot, and boom, right here. This is that same topic as the first question. So hopefully at this point, after finishing the second of the video series, you can see the structure immediately and know what to do. So at a college, approximately 2 out of 5 seniors go on to attend graduate school, right? If there are 750 seniors at this college, how many would you expect to attend the graduate school? Well, if that's the case, got it? Ratio and rate, right? So hopefully you guys are comfortable at this point on how to solve it. Remember, ratio and rate are lovely problems in that it really can't get all that complicated. A lot of the structures are extremely similar. So we look at what the numbers we are given, right? We have 2 out of 5 seniors, right? And then we also know that the total is going to be 750. So we're looking at a ratio. If we know that it's going to be 2 for every 5 seniors, so 2 for every 5, let's just do that to show the ratio, right? If we have a total of 750, right? 750 total. I wrote it in the wrong area. Let's keep it in the correct area just for, lack of confusion's sake. Right? 750 total, right? How many would be going to graduate school? These are the students going to graduate school. These are out of the total seniors, right? So let's look at this. Now, once again, you can always just keep multiplying or keep increasing until you get to 750, increasing at the same rate. Every time you increase this by 5, you have to increase this by 2. So if you're talking about 10, there's 4. If you're talking about 15, there's, what is that? 6, right? So on and so forth. Now, that's going to take a long time with 750. So luckily for us, we always remember, we just can figure out what multiply 5 to become 750. And that same number, we're going to multiply 2 by that number. So if we're not sure, we can't see it right away mentally, right? So then if that's the case, we just figure it out, right? 750 divided by 5, what is that? That goes in there 1 time, 5, 25 goes in here 5 times. So it's going to subtract 25. And of course, there's a 0 and then you bring a 0 up here. So 150. So that means you have to multiply 150 5 times to get 750. So that means you have to multiply 150 here. Right? So that's simple. 300. There There it is, right? Just like that. Now, once again, is there a way to make this complicated? Yeah, probably if you change the number, but luckily for us, the structure is always going to be the same. Solve it this way, or, you know, you could always do cross multiplication, right? So cross multiplication, once again, you have 2 over 5, and then you have 750 over some number that you don't know, and that's what you want to find out. Cross multiply, solve for x, you should get the same number. All right, so another question for you then. Now, if I mentioned in the beginning of the video that a bulk of the problems today are going to be covering this one topic, and there are 5 problems total, what are the chances that the next one is covering the exact topic? Pretty darn high, right? Because we already covered one, and I told you the first one is not. So you have 4 more, and if it's a bulk, right, that's, well, you know, a good chunk of it, more than half. So 3 out of the 4 remainder must be it. So there it is, right? So this is the topic that I'm talking about. The Mills Library has 1,007,199 books. The Springvale Library, right? Springvale Library has 907,082 books. Which of the following is the best estimate of how many books Mills Library has than Springvale Library? So here's the thing. The primary focus of this is called rounding, right? It's this idea of estimating and getting as close as possible. Now, there are some problems, not these in particular, but there are some, if I remember correctly, in the test where it's sort of, I understand that the focus is on rounding, but it sort of defeated the purpose of rounding. Because remember, the idea of rounding numbers is to try to get as close as possible so that you have something that is usable without having to make an extra or greater deal of time, right? Without having to spend an extra or greater deal of time. So if that's the case, guess what? Rounding should usually be less accurate. If you can get a more accurate answer, then that's usually the one you would probably prefer. So that's the thing with these problems. This particular problem, I think some of the other ones are okay, but there are some where, ironically, the more accurate answer is incorrect, and they want you to choose the less accurate answer, which is, it mind baffles me, right? What's the point of estimating if you want to choose the more wrong answer? But anyways, that's beside the point. That's just my little rant. For these kind of problems, use your best judgment. They're usually pretty good at letting you figure out where you should round to. Try to be, I guess you could say, find the middle ground of being specific and just too general. So, for example, this one is fairly reasonable, okay? You want to round these two numbers and then you're going to subtract them. Well, this one right here is 1 million and blah, 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 right? This number, 7,000 something, is actually relatively small compared to 1 million. And hopefully at this point, you're pretty comfortable with rounding, right? General rule for rounding, if it's 5 or higher, you round up. If it's, lower than 5, then you round down, okay? Plain and simple. So in this case, right, we're looking at this 1 million, right? We're rounding this large number. We're going to look at the number right next to it. Well, it's 0. That's clearly less than 5, so we round down. That's just 0 at that point. All right, cool. So this one right here, the estimate, it's about 1 million. Hopefully you guys can see this with the red right here. All right, now this one, once again, it's fairly obvious what to round it. Round the thousands or 100,000, right? So in this case, it's going to be 900,000 because guess what? Right next to it is a 0, so you're going to round down. So this is about 900,000. Okay, and so if you're trying to find the estimate of the difference between Mills Library and Springvale Library, right? All you have to do is just get 1 million, subtract 900,000. And if I remember correctly, that is just 100,000, and that is the desired answer. Okay, so for a problem like this, plain and simple, change the number around, make sure you are comfortable with rounding numbers, right? Just be wary of certain situations where sometimes if you do the actual computation, so you get this and you subtract that, all of a sudden the answer seems more tailored towards another answer. With estimate problem like this, they want you to round before you start solving the problem, not round the answer after you got the more accurate answer, I guess you could say. All right, so that's me stumbling along trying to explain basically my train of thought. So you can guess the next one I'll let you know right now is also a rounding problem. Let's take a look at that. All right, so this is our third problem, and this is by far my favorite problem. Even though it's just a rounding problem, you can guess why. Got it? No, it's not because it's easy or anything. It's because it's such a short problem. I've written so much large, long word problems that this is a wonderful break, right? So, which of the following is the best estimate for 4,286 times 390? Now, hopefully at this point it's fairly simple. We're going to look at this one, and it seems like that's the main focus. If they want you to round like nearest, like hundreds, tens, they usually are pretty descriptive of it. So if you see that they don't describe anything, just think about it as the largest possible. So if we look at the first one, this is a 4,286. We want to round the number. Well, the next number next to it, right, is 2. That is lower than 5, so you're going to round down. This is about 4,000. Okay, we're going to multiply. This one, we have 390 right here. The number next to it is a 9. That is above 5, so you're going to round up. Right, so in this case, instead of 390, now we're going to estimate to be about 400. At this point, hopefully you guys can see, this is a fairly easy multiplication, right? 4 times 4 is 16, and then you just put the number of zeros in the back. There's a total of 5, so 1, 2, 3, 4, 5. You want to be more precise. You put a comma after every 3 digit. There it is, 1,600,000. That is the answer for this, right? Now, this is a good structure, right? All you can do, or all you need to do to make it more complex, just throw a bunch of random numbers and multiplying it. And then an easy way to check is after you round it, right, just multiply it out. Even with a calculator, you don't have to do it all by hand. With a calculator, just see how close your number is to the actual answer, right? That gives you this general understanding of rounding and estimating number. So there it is. An easy one, not too bad, and my favorite one because there is so little words. The next one, not so much a favorite one. Now you can see why this is my not so favorite one, right? It's a fairly long one, actually extremely long. It took me a while to write this. The lowest point on Earth is the bottom of the Mariana Trench at a depth of 35,840 feet below sea level. The highest point on Earth is the summit of Mount Everest at a height of 29,028 feet above sea level. Which of the following is the best estimate of the distance between the lowest and the highest? So once again, we're talking about estimates. So we're rounding, right? Now, the only caveat I can see this potentially causing trouble is the idea of understanding what is below sea level and what is above sea level. Other than that, it's a standard estimation problem, right? So first and foremost, let's just round these numbers very quickly. Once again, we're looking at 30,000 something. We're looking at the 3 right here. The number next to it is a 5. 5, that means you round up. So this is about, and this is the about symbol, 40,000. Okay, so this one right here, this one is 29,000. Once again, we're looking at it here, that's 20 something thousand. 9 is clearly above 5, so we're gonna round. This is about 30,000. Okay, plain and simple. Now, this is where it can get a little more complicated. Why is that? Well, let's see. This is about 30,000. This is about 40,000. Now, it doesn't look like there's the potential of the answer. So these are the potential answers that they give you, right? So that means not clearly or very well written, we have to change the estimate a little. Okay. Well, first and foremost, let's just look at this really quickly. Understanding that below sea level means that there's this threshold, there's this 0. Everything under it is below, everything above it is, well, above sea level, right? So if you're trying to find a difference, notice that you have this above and a below. Think of the below as like a negative number. So you not only have the difference between this and 0, but you have from 0 to the bottom as well. So that's the point of this. So that means we have this one that's above, this one that's below. If we add those two together, that's the total difference, right? That trespass, I don't know, crosses the 0 line. And then afterwards, you basically have your above and below sea level, right? So that's about 40,000, that's about 30,000, that should be about 70,000. The only problem is we don't see that. So that means we have to change the estimate a little. Well, this one I still think is about 30,000 because that's pretty darn close. This one, maybe we need to be a little more precise. Maybe we shouldn't talk about 40,000. Let's look at the next number in. So it's going to be 35, and this number right here, right, is the next number that we're considering for rounding. Well, this one is clearly greater than 5. So in this case, the next estimate that we're going to do is about 36,000. Now, if we add those guys together, that's about 66,000. Boom, 66,000. That is a potential answer and most likely the answer that they are looking for, right? So there it is, plain and simple. That's how you would go about a problem like this. Is it well written? Not really. I don't like the fact that they didn't specify exactly how to round it. But you always have the tools. If it's too inaccurate, try to be a little more accurate in this point. Remember, the only difficulty with this problem is that estimation and the understanding of below and above sea level. Once you get that down pat, find problems that are similar or just change this around. Understand that the below and above sea level are just another way of saying potential negative number and positive number. And if you find a difference, minus and minus is a plus. That's another way to think about this. So there you go, another rounding problem. Let's move on to the next one. And I am happy to announce it is a different topic. All right, so let's look at this final problem for today's video. Remember the fifth problem. This is problem number 15, right? So there is a top section of the problem. Imagine scrolled up, you can't see it, but the idea is fairly simple. It was something along the line of a student named Kim who took a standard science class, and this is the score that he got for either a test or quiz, one of those tests probably, because it talks about tests. All right, so they give you this basic graph or basic, I guess you could say, table with data points, and then all of a sudden they ask you which of these following are the most accurate representation of what you can get from this table. Now, it's fairly simple, right? Usually when they give you problems with tables and stuff like that, it's not something really complicated that you have to sort of read between the lines. It's usually just smack dab in your face, right? Now, the other thing is that you always have to make sure that you are getting the exact information that is given to you, or whatever information that you are able to get is logically sound. You can derive it almost immediately, right? No questions asked, nothing can be used to debunk it, right? It is going to be sound. So that's one of two possible situations. Either the answer itself, the information itself is smack dab in your face, or it has to be so easy to get that there's no questions asked. So let's look at each and every one of them and see if we can infer that from the table or it's presented in the table itself. He scored as well or better than 72 of the test taker. What is 72? 72 is the raw score. So there's no way you can come to that conclusion, right? As better than 72 of a test taker. We don't even know how many test takers there are. So A is definitely not it. So let's just do that. Nope, that's not it. All right, the second one, 28% of the test takers scored better than he did. We don't even know where they got 28. Probably, my guess is that they got 100 and they subtract 72, and that's why they got 28. Nowhere does it mention 28. How would you know that 28% of the test takers scored better than he did, right? There's nothing that says that. So, no, doesn't work. Third one, he would perform adequately in a 12th grade science class. Okay, yeah, probably, but I mean, how would you know? So it doesn't work, right? So you can't just start inferring things that there's no real way to back it up, right? I mean, who knows? He might be able to perform very well, or he might end up going to a 12th grade science class and then, you know, do terribly, get into some very unproductive habit. Who knows, right? So there's no way that's an answer. Let's look at the D and E. He scored as well or better than 88% of the test taker. That is a possibility because here it says percentile. If he's in the 88th percentile, by definition of percentile, basically he scored better than 88% of all the test takers. That's possibly it. Let's look at the last one just in case. He answered 72% of the questions correctly. I mean, if, and this is a big if, the test has 100 questions, then yeah, that's probably, and each and every one of them is a 1, but I mean, there's no way we can figure that out, right? So, no, this is not it. So, out of all of them, this is the most likely the correct answer and the most probable one, because that's the only one where you can really get that information from the table. Everything else is really potentially very far stretch inference, right? So that's what you would do with problems like this, and there's going to be a lot more problems that I want to say fall under the category of more information gathering that you will see in future video series, where, remember, you're either trying to get the actual information from whatever is given, or whatever information you can get or conclude can be strongly tied by some logical deduction, and there's no way to debunk it. So that's our 5th question. All right, so there you have it, another 5 questions. That is 15 total right now. That means there are 35 more to go, 7 more videos. Now, of course, it seems kind of daunting that there are 7 more videos, but each and every one of these videos, I'm hoping that you get something more than just the problem itself. For this video, of course, hopefully you guys got the concept of rounding, right? 3 of the problems out of the 5 was focused on rounding. And now, that's the thing with rounding, right? We want to be as precise as possible without getting the actual answer, because the whole point of rounding, the whole tool of rounding, is for you to estimate more accurately without having to waste so much time. But in one of the problems, if you guys were paying attention, right, we became too inaccurate and we actually had to become more accurate, right? It was the 40,000, and then it ended up that we couldn't just go with 40,000. We actually had to go, I think it was like 36,000. Can't remember right now. But basically, that's the key of rounding. Now, hopefully from that, at least the main point from all the problems that we went over today, you understand the concept of rounding, how to approach rounding, and how to scale it back or become more accurate. And of course, there's also this problem, which I think is a wonderful prelude or introduction to potential similar problems, where basically they're asking you to gather information. And remember, when they're asking you to gather information, always get what you can for sure logically back up, right? No inference, no long stretches, any of that sort. Hopefully you find this entertaining, or at least, you know, watch me suffer while I basically, it's like a little kid's punishment, where I write down the entire word problem, right? Thank you for watching. If you haven't already, please like, comment, and subscribe. I will see you in the next video.